Okay. Hi guys. This is going to be the intro video for the alternating series and the alternating series test. So let's start with the definition of an alternating series. It is just a series. Alternating series is a series whose terms alternate between positive and negative numbers. So the word alternating just refers to the alternating signs of the series. And typically, an alternating series has two forms. So the first one, I want to write it as b1 minus b2 plus b3 minus b4, and then plus b5 minus b6, etc. So when I'm writing this, I'm assuming that the terms b sub I, they are all non-negative for all I. So this first example that I'm writing down here is just an alternating series that start with a positive number. So as you might be able to guess, the second form is an alternating series that start with a negative number. So negative b1 plus b2 minus b3 plus b4, etc. And there's a way to write them a little more concisely. So for this first form, I can write as a sum from n equals 1 to infinity b sub I. Now, the first term is positive. So for this case, I have to write -1 to the n plus 1. Okay. And for this second form, it's still the sum from n equals 1 to infinity. Now the first term is negative, so it's -1 to the n b sub I. Okay, so that's what alternating series is. Just so you have an example, let's look at this. Just one example. For example, if I have an alternating series with the first term positive, 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5, etc. Well, this is an alternating series. In fact, it looks quite like the harmonic series, and I believe that we're going to work with these in one of the homework problems. Okay, so let's think about all the series that we've been working with are mostly series with positive terms. And all the tests that we have, for example, divergence tests, integral test comparison tests, and limit comparison tests. In particular, these tests, they only work for series with positive terms. Well, in fact, same is true for P series. We really only think about series with positive terms. Now, the divergence test does works for all kinds of series, all types of series, but it only tells you when a series diverges. So if it doesn't say anything about convergence. Now, the geometric series does work with negative terms, but is a very special type of series. So a lot of times it might not apply. So we are in dire need of a test that tells us the convergence of alternating series, and that's the alternating series test. So the test says that if we have an alternating series of the form, either this, let me change the color actually, these two forms. So the first form simply means that you're starting with the first term is positive, and then this just means the first term is negative. So an alternating series converges if, well, the first condition is that the terms are decreasing. Well, when we say decreasing, it really means that it's not increasing. Okay, the second condition is that the limit of the term goes to 0. So maybe you can say it like an alternating series converges if the terms are decreasing to 0. So intuitively, it just says that your terms have to be decreasing, and as long as the limit of the term goes to 0, your alternating series converges. Okay, so for the last part of the video, I'm going to talk about absolute and conditional convergence. So what I mean, I need to define these two terms. So let's recall that the alternating series test, as we just talked about, determines whether an alternating series, alternating series such as, the sum from n equals 1 to infinity, a sub n, converges. Now, this might be a natural question to ask, is that what about the series where I only look at, I say that these a sub i's here right now, they can be positive or negative, but what if I just make them all positive? So what about the corresponding positive series? So it's still the sum from n equals 1 to infinity, but now I take the absolute value. So does this series converge? Or better, is there a relation between these two series? So what I mean by that is, so for example, if this series converges, does it say the convergence of this alternating series, or the other way around? If the alternating series converge, can I say anything about this series with absolute values? Okay, so in fact, only one of the directions is true, which is the following theorem. It says that if the series with the absolute value converges, then the series without the absolute value also converges. And we have a special name for these. If a series is such that, let's say such a series. So if a series satisfies that it converges itself, and also if we take the absolute value of every term, series still converges, such a series is called, is said to be absolutely convergent. Okay, now the other direction doesn't work. So the converse of the theorem is not true, it's false. So what does the converse say? The converse says that if my original series, an, converges, this does not imply that the corresponding positive series with the absolute values converges. So this converse gives us another definition. So if a series an converges, but the series with absolute values diverges, then this original series is set to be conditionally convergent. Okay, we'll talk a little more about these in class, and I think I'll stop here.